Chelsea, I really wanted to do this sad or not nice information opener for the week for our Fringey mini, but it was behind a paywall. So unfortunately, you will have to settle for a sciencey one.
Saved by a paywall. Maybe we needed to know that information.
I think we did, but not everybody's going to agree with me on that.
Maybe one day someone will send us some money to get behind the paywall.
Yeah, it's a Wall Street Journal paywall, so I don't think we want to.
Never mind whoever was opening the app to send us some money. Okay, let's hear the article.
You can still send us the money, please.
Okay.
We could use the money. Chelsea, this one I found interesting. It might not be that interesting, but there's a few things that we kind of think we know about the universe. One of those things, the Big Bang happened 13 billion years ago-ish. Here's an article from phys.org, published by Bernard Risk of the University of Ottawa on July 13th, 2023. New research puts the age of the universe at 26.7 billion years, nearly twice as old as previously believed. Our universe could be twice as old as current estimates, according to a new study that challenges the dominant cosmological model and sheds new light on the so-called impossible early galaxy problem, which we talked about in an early episode, so this one's a bit of a follow-up on that. The work is published in the journal Monthly Notices of the Royal Astronomical Society. Our newly devised model stretches the galaxy formation time by several billion years, making the universe 26.7 billion years and not 13.7 as previously estimated, says author Rajendra Gupta, adjunct professor of physics in the Faculty of Science at the University of Ottawa. For years, astronomers and physicists have calculated the age of our universe by measuring the time elapsed since the Big Bang and by studying the oldest stars based on redshift of light coming from the distant galaxies. In 2021, thanks to new techniques and advances in technology, the age of our universe was thus estimated at 13.797 billion years old using the Lambda CDM concordance model. However, many scientists have been puzzled by the existence of stars like Methuselah that appear to be older than the estimated age of our universe, and by the discovery of early galaxies in an advanced state of evolution made possible by the James Webb Space Telescope. These galaxies existing a mere 300 million years or so after the Big Bang appears to have a level of maturity and mass typical associated with billions of years of cosmic evolution. Furthermore, they are surprisingly small in size, adding another layer of mystery to the equation. Zwicky's tired light theory proposes that the redshift of light from distant galaxies is due to the gradual loss of energy by photons over vast cosmic distances. However, it was seen to conflict with the observation. Yet Gupta found that by allowing this theory to coexist with the expanding universe, it becomes possible to reinterpret the redshift as a hybrid phenomenon rather than purely due to expansion. In addition, Zwicky's tired light theory, Gupta introduces the idea of evolving coupling constants, as hypothesized by Paul Dirac. Coupling constants are fundamental physical constants that govern the interaction between particles. According to Dirac, these constants might have varied over time. By allowing them to evolve, the time frame for the formation of early galaxies observed by the James Webb Telescope at high redshift can be extended from a few hundred million years to several billion years. This provides a more feasible explanation for the advanced level of development and mass observed in these ancient galaxies. Moreover, Gupta suggests that the traditional interpretation of the cosmological constant, which represents dark energy responsible for the accelerating expanse of the universe, needs revision. Instead, he proposed a constant that accounts for the evolution of the coupling constants. This modification in the cosmological model helps address the puzzles of small galaxy sizes observed in the early universe, allowing for more accurate observation. So that's the article. Chelsea, what do you think? Anything to say on it?
Not really. I mean, it's all really cool things that we're starting to find out about the universe. It seems like everything I grew up knowing is all wrong and it's all new and shiny now all the time, but it's not ever really anything that I completely understand.
No, but every time we get a better way of measuring, we find out how we're fundamentally understanding it or might not be correct. And there's two things that we really don't understand, and we just call them dark matter and dark energy. And this does seem to somewhat take away the problem of dark energy, the thing that we just can't measure. So that's a cool thing. That means we kind of understand a bit more of the universe. But I always like the quote, we pretty much understand everything except the really big and the really small and the really hot and the really cold and pretty much everything.
Yeah, that's a good way to put it.
Yeah, just a new proposal out there, fundamentally changing and answering the question of these old galaxies. So following up to that one intro that we did, and I can't remember which episode, but that's okay because these are Fringey minis now.
Yeah, enjoy.
Chelsea, anything else to add?
No.
Well, I hope you all have fun reveling in the infinitesimal size of your existence in this universe. And
a nice start to our Wednesday.
While you cope with that, we'll see you on Friday.
Bye.